Find the 25th term of the arithmetic sequence 5, 12, 19, and 26. In this arithmetic sequence, we have the first term is equal to 5. The common difference is 7. Why? Because 12 minus 5 is 7, or 5 plus 7 equals 12. Next, n is equal to 25 because we're looking for the 25th term. And so the question actually is, what is a sub 25 or the 25th term? Our basic formula is a sub n is equal to a sub 1 plus quantity n minus 1 times d. So we are looking for a sub 25. It's equal to a sub 1, 5, plus n, 25, minus 1, times d, which is 7. Or this is equal to 5 plus 24 times 7. Or 5 plus 24 times 7 is 168. And finally, this is 173. That is a sub 25 or the 25th term. What must be the value of k so that 2k minus 7, k plus 5, and 3k plus 2 will form an arithmetic sequence? So in this problem, we are given that 2k minus 7, k plus 5, and 3k plus 2 must form an arithmetic sequence. So if they must form an arithmetic sequence, there must be a common difference. That is, if we subtract second term minus first term, and then third term minus second term, the differences must be equal. That's why we call it common difference. So let's write that down. K plus 5 minus quantity 2k minus 7 must be equal to 3k plus 2 minus k plus 5. Let's now remove the parentheses. K plus 5 minus 2k minus 7 becomes plus 7 equals 3k plus 2 minus k, and then plus 5 becomes minus 5. K minus 2k is negative k or negative 1k. 5 plus 7 is positive 12. It's equal to 3k minus k, 2k, and then 2 minus 5 is negative 3. Further, let's proceed to collect similar terms. We have negative k. Let's get that 2k. Let's transpose it to the left. It will become minus 2k equals, we have here negative 3. Let's get that 12 at the left. Transpose it to the right. It will become minus 12. So negative k minus 2k, that is negative 1k minus 2k, which is negative 3k, equals negative 15. Then let's divide both sides by negative 3. Cancel. Finally, k is equal to negative 15 divided by negative 3, positive 5. Find the common difference, or d, and the first term, a sub 1, if a sub 4 equals 10, and if a sub 11 is equal to 45. Let's answer this problem now. We are given that a sub 4 equals 10 and a sub 11 equals 45, and we are asked to find the first term and the common difference. We're going to use the formula for the nth term. The formula for the nth term of an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. So let's do it for a sub 4. Therefore, a sub 4 will be a sub 4 equals a sub 1 plus n minus 1, that is 4 minus 1 or 3 times d. For a sub 11, it will be a sub 11 equals a sub 1 plus 11 minus 1 is 10. 10d. Okay, let's go back to a sub 4. 10 equals a sub 1, which is unknown, plus 3d. Here, a sub 11 is 45. 45 equals a sub 1 plus 10d. If we transpose here 3d to the left, that will become 10 minus 3d equals a sub 1. And here, let's transpose 10d to the left. This will be 45 minus 10d equals a sub 1. Now we can proceed to solve for a sub 1 and d. Take note that this is equal to a sub 1 and this is also equal to a sub 1. So putting this together or substituting, we have 10 minus 3d equals a sub 1, but a sub 1 is also equal to 45 minus 10d. Let's transpose negative 10d to the left. So we have negative 3d, get that 10d plus 10d equals, we have 45 at the right, then we get that 10, which will become minus 10. Negative 3d plus 10d is 7. 7d equals 45 minus 10 is 35. Let's divide both sides by 7. Therefore, d equals 5. To solve for a sub 1, let's just choose one equation. Let's say we have 10 minus 3d equals a sub 1, or a sub 1 equals 10 minus 3d. Thus, a sub 1 equals 10 minus 3, and we have solved for d, and d was equal to 5. Therefore, a sub 1 equals 10 minus 15. A sub 1 equals negative 5.